Today we're working on proportions and similar figures. Before we get started with any examples, I want to go through a few important things here. First of all, at the bottom, this is telling us triangle ABC is similar to triangle DEF. That's important for a few reasons. Number one is similar to. That means that you have two triangles or two shapes, whatever the shapes are, that are proportional. It's just that one is bigger than the other. It's also important to pay attention to the order of the letters. This is saying triangle ABC is similar to triangle DEF. Since they're both facing the same way, we can assume that the blue sides are proportional, the red sides match, and the green sides match. Sometimes they'll flip one of the shapes upside down, they'll rotate it, they'll put it on its sides. You just have to be careful to match up the appropriate sides. Okay? So here we go with an example. Again, they're telling us triangle ABC is similar to triangle DEF. And then side AB is 20, side BC is 18, EF is 12, and then we have to figure out DE because that's Y. So we want to set up a proportion. Remember, a proportion is something over something is equal to something over something. And there's a lot of ways to set this up. You just have to make sure to match the appropriate sides. So one way that I could do this is 20 over 18, okay, and I'm color coding so you could see here, equals Y over 12. So notice that because I put 20 in the numerator in the first fraction, I have to put the Y in the numerator in the second fraction because they're both in the corresponding positions. Another way to do this would be to put the 18 on top over 20. And then in the other fraction, because I put 18 on top, I need to put 12 on top. And then I'll put Y in the denominator. Another way would be to do 20 over Y, and now I'm going between triangles, so since I put the 20 on top, I need to put the 18 on top over 12. All those are acceptable. So I took this fraction here, I took this proportion, 20 over Y equals 18 over 12. You could do any of these because let me just show you this. When you're cross multiplying to solve for all these, you're going to end up multiplying 20 times 12, 20 times 12, 20 times 12. And then in the other cross product, you'll do 18 times Y, 18 times Y, 18 times Y. So you end up with the same problem no matter what you do. It just depends which way you set it up. So again, like I just said, we're going to be cross multiplying 20 times 12, which is right here, and then 18 times Y. And notice I put the equal sign between those two. And now we just solve. So I'll separate the two sides of my equation. I can simplify 20 times 12, which is 240. And now since the 18 is attached to the Y with multiplication, we'll divide by 18 on both sides. And we end up with Y equals approximately 13 3/10. Remember that bar on top of the 3 just means that it's repeating. So when you type that in your calculator, you'll get 13.3333 on and on and on. So you just put the bar to indicate that it's repeating. All right, another example. It says a tree casts a shadow 7.5 feet long. A woman 5 feet tall casts a shadow 3 feet long. How tall is the tree? Whenever you have a problem like this, draw a picture. As silly as it looks, here's my picture. We've got a woman. We've got a tree, and then remember a shadow. Think about where a shadow would be. A shadow would be along the ground, so here's my shadows for each of them. And what they're telling us is that the tree casts a shadow 7.5 feet. So this distance right here is 7.5. Since they're all feet, I'm not even going to write that in because I don't have to worry about converting anything. So I'll put that in at the end. So the shadow for the tree is 7.5. The woman is 5 feet tall, so her height is 5, and she casts a shadow that's 3 feet long. And now we need to figure out the height of the tree. So that's going to be our variable x because that's our unknown. So then I set up my proportion. Again, many different ways to do this, but I chose to put 3 over 7.5 is equal to 5 over x. Again, you've got to match up the appropriate sides. And now we can cross multiply 7.5 times 5 and 3 times x, which would look like this. And then just solve. Separate the two sides. 7.5 times 5 is 37.5. 3 is attached to the x with multiplication, so we'll divide by 3 on both sides, and we end up with x equals 12.5. Remember, in the problem we were talking about feet, so make sure you include your units when you're done with the problem. So the height of the tree is 12.5 feet. And our last problem, scale drawings. It says the scale of a map is 1 inches to 10 miles. Find the actual distance. So you're looking at the map. We did this the other week where you actually had to measure. So you measured that it's 1.75 inches on the map. And you want to figure out how many miles that actually is. So again, we need to set up a proportion. So I chose to do 1 over 10. So 1 inch over 10 miles. And since I put inches in the numerator here, they tell me that I have 1.75 inches, so I need to put that in the numerator over x miles in the denominator. And now we'll cross multiply, so that would be 1 times x, and then 10 times 1.75, and 10 times 1.75 is 17.5. And since 1x is the same as x, I don't even need to divide, so 17.5 miles is the answer. And that's all. So that's it for similar figures and scale drawings. Bye, guys.